Now, what kind of problems will you see on this chapter? You will definitely see problems a with the formulas that look like this. Um, and delta E is negative 2.18 times 10 raised to negative 18, 1 over final n square minus 1 over initial n square. Say, for example, you will come up with a problem like this, or you will come across a problem like this. What is the energy of a microwave radiation with wavelength 2.3 times 10 raised to negative 2 meters, right? So they're telling you that it's a microwave radiation, that this is the wavelength. They're asking you for energy. So essentially you have to connect wavelength to energy. Wavelength is lambda, energy is E. What's the formula that's connecting wavelength and energy? E is equal to hc over lambda. So then 6.626 times 10 raised to negative 34 joules second. This is Planck's constant, and this value is on the periodic table that I gave to you, multiplied by 3.0 times 10 raised to 8 meters per second. This is the speed of light, and this is also on the periodic table that we gave to you, divided by lambda, which is 2.3 times 10 raised to negative 2 meters, and this is the wavelength given to you. So then you cancel out the units, and then you come up with, go ahead and check the answer, 8.6 times 10 raised to negative 24 joules, right? And you will see a variation of this kind of problems. So you might get problems which might have any of these formulas incorporated in them. Another problem could be when an electron in hydrogen atom transfers from fourth level to third level. How much is the energy that is released, or how much energy is released? How much energy is released, right? So then they gave you two important pieces of information. The electron is jumping from the fourth level to the third level. So this is n initial, it was initially at fourth level, and this is n final, it's finally going to the third level. So your formula for this, as we have seen in the previous slide, delta E negative 2.18 times 10 raised to negative 18 over 1 over nf squared minus 1 over ni squared, and this would be negative 2.18 times 10 raised to negative 18, 1 over 9 minus 1 over 16. Where did I get the 9 from? Nf squared, and I got the 16 from ni squared. And this will be negative 1.06 times 10 raised to negative 19 joules. And what's the other kind of problem or conceptual questions that you will see? Say for example, they might ask, you might come across a problem, how many subshells? How many subshells are in n is equal to 3? How many subshells are in here? Now remember, this is the main shell, right? N is equal to 3 is the main shell. How many subshells are there? What is a subshell? Subshell is the L value. So then if n is 3, so essentially what they are asking you is, if n is 3, what is L? So L can have now 3 values, 0, 1 and 2. And where do we stop? We stop at n minus 1, which is in this case 3 minus 1, so it is 2. Now if this question had a variation, and instead of asking you how many subshells, if they had asked you how many, instead of asking how many subshells, if you came across a question, how many orbitals? They're not asking you subshells, but they're asking you how many orbitals are in n equals 3, right? So now they're asking you for orbitals, which means you're looking for m sub L value. Now think about it. Every n is associated with many m sub L values, right? So how do we figure that out? So if n is 3, L can be 0, 1 and 2. Now each of these will have its own m sub L. M sub L here is 0. M sub L here is -1, 0, +1. And in this case, m sub L are -2, -1, 0, +1 and +2. So there are totally 1, 2, 3, 4, 5, 6, 7, 8, 9 orbitals in a single shell n equals +3 or n equals 3. Now they're asking you how many orbitals are in just this level. They're not asking you how many are in n1, n2 and n3. They're just asking you how many in n3. Now if they would have asked you how many, or if your question was how many orbitals are in an electron all the way up to n3, then you would consider for n1, n2 and n3. In this case, they've asked you just the n3. Now instead of how many orbitals, if you would have seen a question, how many electrons are in n3, right? Then your answer would have to be different. So n3, L0, 1 and 2, m sub L 0, m sub L -1, 0, +1, and m sub L -2, -1, 0, +1 and +2. And remember, each one of these can have a maximum of 2 electrons. So 2, totally 6 and totally 10. So this will take a maximum of 18 electrons. So N3 can accommodate a maximum of 18 electrons. Now some other type of conceptual questions could be, why is 2D not possible? Right? You have 1s, 2s, 2p, but you don't have 2d. Why is it not possible? Remember, in your orbital or in your subshells, this is the n value. So n is 2, L would be 0 and 1. If L is 0, the sublevel is called as S, and if L is 1, it's known as P. So there is no D here. So this is why 2D is not possible. So these are some kind of questions that you will come up with in this chapter.